Hi, Honors Chem. We are finding the empirical formula. We're in Unit 6, Chemical Reactions, the unit that never ends. Oh my God. It's okay. So, finding the empirical formula is pretty easy. Okay, it's just the simplified version of a formula. You can see that C2H6 is divisible by 2, and that is how I'm getting this ratio. Really, what it means is for every carbon, there's 3 hydrogens. I wish I had $3 million for every dollar I make. It's not going to happen. So the steps for finding the empirical formula, I'm going to put this in every slide. The very first thing we do, change the percent sign to grams. Then we convert from grams to moles, divide the smallest number of moles by all the other ones, and then we write the empirical formula. Metals go first, and then it's least electronegative to most, unless carbon is in our formula. Then you write it first because carbon is your favorite, hopefully. Hopefully carbon is your favorite. You know what? I'm not going to tell you what your favorite should be. Maybe you like oxygen. I'm not going to judge. Okay, so here we go. Here's our first example. We've got something that's 15.8% carbon and 84.2% sulfur. We want to find the empirical, so the first step, convert those percent signs into grams, and it's literally just as easy as writing grams instead of percents. Whee! Oh, goodbye. And then, next step is converting grams to moles. So how do you do this step? Well, you gotta look on the periodic table, and you have one glued to the inside of your notebook. The mass of 1 mole of carbon on the periodic table is 12.011 grams. The mass of sulfur for 1 mole of sulfur on the periodic table is 32.066. And so all I have to do is that little conversion, and when I do that, out of these two numbers, since I'm on step number 3 now, 1.315 moles is smaller. In fact, it's the smallest out of the two. So that's the one that I'm going to divide the other number by. And I'm also going to divide that little number by itself. So that's why I drew a dividey sign, and I put 1.315 underneath it. When I divide that number by itself, it gives me 1. When I divide 2.626 by that number, it gives me 2. That's how I know there were 2 carbons. I'm sorry, 1 carbon and 2 sulfurs. And that's what we're going to say in this slide. So over here, you can see that that little number that I figured out from before is telling us how many atoms we have of each different type of element. Oh, something is happening. That's weird. Okay, example number 2. We want to find the empirical formula of a compound that's 40% carbon, 6.7% hydrogen, and the remainder is oxygen. So, guess what? Percents are always out of 100. So I'm going to add 40 to 6.7, which gives me 46.7. Then I'm going to subtract that number from 100, which is how I get 53.3. And now I'm actually ready to start solving this problem. So step number 1, remember, change percents into grams. That's the easiest step of the whole thing. Yay. We did it! That's what that check mark means. Step number 1, complete. No. And then, moving on to step number 2. Whoa. We're going to convert grams to moles. Once again, you gotta use your periodic table. That's where I get these numbers from. Oh, look. I'm not gonna ever let you forget it. Use your periodic table, right? You can find the mass of 1 mole of hydrogen on that thing, the mass of 1 mole of oxygen, and the mass of 1 mole of carbon. Whee! Oh. Okay, step number 3. We have to divide the smallest number by all the other numbers that you see. And in this one, it's kind of tricky because we have two numbers that are kind of the same almost. I'm going to just choose the smaller one of the two. So the number that I'm going to divide all the other numbers by is 3.330. We're almost done. All we had to do was write them in order. Carbon comes first if it's present. And then that's it, you guys. Don't give up. Chemists try. And try again and try again. It's okay. I'll see you tomorrow.